Thank you.
So we have the recovery master assembly. Obviously, we don't include the parachutes. We also don't need to include the taco link cable. These CO2 covers. Okay, it's slow. Am I freezing for, okay, my Zoom was kind of going slow. So these CO2 covers and fasteners, I also deleted. And I got rid of these guys, all these blocks on the back, basically because ANSYS, or like the free version of ANSYS, can't handle too many faces, and there shouldn't really be too much load on them compared to the bulkhead, and they're steel, so they're stronger. And when you start getting too many like connections, your simulation gets kind of bogged down and can be less accurate. Also, these set screws, I deleted those because you can basically you model your joint from to the ground or to, whatever in ANSYS, so you don't need the set screws. And so that's kind of my version 1, basically just the bulkhead, the taco link, and the eye bolts. But the load, and the nuts, but the load was not really transferring to the bulkhead, just because it's hard to model like threads and stuff. So I ditched the eye bolts and just did the bulkhead and the pins. That looks like this. So this is the step file, but once you have your part or assembly that you want to do FEA on, basically just save as step file and make sure you go under options and make sure this is not selected, because this will split all the holes in half, and then you can't use some of the features, and you also have to like select 2 faces every time you want to select a hole. So that's how I made the step file. So once you have that, we're close SolidWorks. Did that all make sense? Does everybody understand like why those components were not included? Okay. So then this is like what you see on Workbench. This is kind of your like main page. And then open up a static structural. So now you get this guy. So double click on engineering data. So this is how you, for whatever reason, you have to like manually import the materials you want to use in the simulation. And also, I really hate this page design. It's really confusing. But so click here to add new material. And if you go at the top, there's engineering data sources. So our bulkhead is aluminum, and then the pins are steel, and then there are brass bushings. So they automatically include a steel. And then you got to scroll through these engineering data sources, and there should be a general materials. You see what I mean by this is kind of confusing for no reason. So we want to add an aluminum alloy. So press the plus button, and then you'll know if it got added to your materials because there's a little book. And then there's not really a brass. The closest thing is like a copper alloy. So I just use that. But you can make custom materials. I've just never done it. And also the main stress is just in the bulkhead, so I think it's okay if the material of the pins are not super accurate. So that's done. I'm just going to go ahead and save this before we get anywhere. Okay, and we're all good so far? So geometry. So right click on this and go to the design modeler. I don't like the other geometry thing very much. I'm just gonna take a second to load. So you can model stuff in here if you choose pane. However, we have a CAD model, so we're just gonna import. So file, import external CAD file.
Can you just hold up for a second? My ANSYS has locked up on me for a second here.
Oh yeah.
I think it's okay, maybe. Oh, wait, so right click geometry and then design modeling?
Yeah.
Oh, it's really slow. Okay, and then I think, yeah, I'm at the same spot you're at now. Thanks.
Okay, so file, import external geometry file, and then you just gotta browse for wherever you put that step file. Okay. And so it doesn't do anything until you press generate. That's basically all the commands in ANSYS. So now you see the model, basically the bulkhead.
Oh, sorry. I accidentally opened the other. It was like Spacescape or something. But I just missed how you imported the step file.
Oh yeah, no worries. Yeah, it's just file, import external geometry file.
Great, thank you.
Browse, and then you have to hit generate. That's all you need to do for geometry. So now if you open up model, this is kind of where the bulk of the work is. This always just takes a second to like actually open up. Okay, there we go. So I'll just give you a really quick like controls tutorial because there are a few things that make your life easier. So if you have hopefully a mouse, so you can just scroll in and out. And if you hold the scroll wheel, you can pan, pretty similar to SolidWorks. This thing down here, if you click on an axis, you'll look at it basically. And if you click on the ball, you'll get the ISO view. If you want to select multiple faces, you hit Control, and you can, select whatever. If you Control scroll wheel and drag, these buttons up here, so you can switch between selecting a point, selecting an edge, face, body. And you can also use this box select. I don't usually use this, but you can it will select everything in your box. Yeah, and then you can, if you right click, there's like hide body, hide all other bodies, suppress body, and those are useful. So first you have to set all your materials. So we just click on this list. They all get the steel material as default. So these are, let me drag this. So the retention pin is steel. So we can leave that also, it lights up. And this is the other one. So that's steel, we don't need to change it. The bushings will change. Assignment, arrow, and copper alloy. We'll change all. And the bulkhead is aluminum, so change that to aluminum alloy. So now we have all our materials set.
Hey, Claire, do you mind moving the Zoom cameras? Yeah, so they can show up as black boxes. Thanks.
So now you have, yeah, materials set. So I usually like to just generate the default mesh first, because sometimes I have had like, I've set so many connections and then it gets like stuck, but I find if you set the mesh first, we'll fix it. But if you set the mesh first, it doesn't get stuck. So when you import an assembly, it will make all these contact regions automatically. And I usually just delete the whole thing. So right click, delete, because they'll probably all be like bonded together, which is not how the parts actually interact. So delete all your connections. So you have to tell ANSYS basically how these parts interact. So I'll start with the bushings and the bulkhead. So I'm just going to click on the pins and the bulkhead, right click, right click, should have been hide bodies, invert visibility. So now we just have the bushings. Do you guys get that? Okay, so right click, insert, manual contact region. So I'm going to first set the connection from the bushing to the bulkhead. So they're press fit in there. So it's kind of going to be like they're bonded together basically, right? Because they shouldn't be able to like move relative to each other and they can't penetrate. So select all these outside faces, contact, apply. So now these 4 faces are contact. And also it doesn't matter like which one's contact and which one's target doesn't matter to my knowledge. And then we can do right click, invert visibility. I'm also gonna hide these. And then click all the faces where those bushings are fit into. And target, click, apply. And if you scroll down, the default type is bonded, so we can just leave that. Did that make sense?
Can you just hold up for a sec? I accidentally set the bodies to be contact, not the faces. So I'll just give me 1 sec to catch up.
You can see in the editor, like the contact body and the target body.
Oh, I don't see the bushings on my contact bodies. Do you think I just selected the wrong ones, or like didn't select them correctly?
Oh, you don't see the what?
Oh, I don't see the red, like the bushings in the contact body view.
Oh, interesting.
So I must have not selected them.
They should be like 4 faces.
See those. Okay.
This is also, this is definitely the hardest part, like the connections and the joints, because you really have to like think about how things interact.
Oh, it was because I was hiding the bushings. That was why.
Oh, okay, nice.
Okay, so if I go to show all, okay, there they are. Nice. Okay.
How do I set the target body to be the bulkhead?
So hide all the, I'm just gonna exit out of that. So hide anything. Like, gotta hide the bushings. So click, control click, hide body. And then you should be able to just select all 4 of those faces. And then like target apply.
Okay. Sorry, I have to select the inside of the, like that bore. Is that right?
Yeah, so hide everything except the bulkhead. The easy way to do that is you could just click on the bulkhead and hit hide all other bodies, and then select the actual bore, and then click target apply.
Okay. Yeah, I'm good now. I'm gonna see what you see.
Yeah, so you can also, so I should mention you don't have to do like every single like surface at a time. If it's like the same for this one, it's like all the bushings in contact with the bulkhead, you can just do them all at once. Because it's gonna know like this bushing's not in contact with that bore. If that makes sense. So I'm gonna go show all bodies. And so now we need to show the pins in the bushings. So insert. Insert manual contact region. I'm going to hide everything except the pins. And then I'm going to select the whole face. I'm not sure why it's split in 3, but just to cover our bases in case there's overlap, select the whole pin outer like diameter that touches. Apply. Target. So we'll go invert visibility, and now you should see just the bushings in the bulkhead. So the target is the bushings where the pins can slide in. So these inside and hit apply. Did that work for everybody?
I think so. I'm just catching up here.
Okay. And so the type, in this case, the pins are free to slide in the bushings. So the type is actually frictional. Also, I should mention, I hid the nylon pins because like ANSYS is not going to simulate like the rocket, like lateral acceleration, like moving these pins around. So they're going to stay where they are. So but they are free to slide along the bushing technically. And you can find the friction coefficient if you just like, I can maybe put this link in the chat if you want, but this is usually just what I use. In case you're curious. So we have a bunch of different material combinations. In this case, we have brass on steel. I just did the clean and dry coefficient. So 0.51. And then also with the frictional coefficients, If the CAD, or I've been having this problem where if the CAD is not like perfect, where they have like perfect like overlap, you kind of get some weird problems. So if you go to, this is still in the contact region window. If you scroll down to geometric modification, this interface treatment, change it to adjust to touch. And that basically just like adjusts the CAD geometry so that it's closes all little gaps and stuff. Did everybody get that? Okay, nice. So that's all we need for actual contacts between parts, bushing to bulkhead and pins to bushings, all bodies. But we also need to like show how this is fixated, like the whole assembly. So under static structural, you can insert like all these things. So what I used is cylindrical support, and this basically, like if you have a hole or like any cylinder, you can specify like how it's allowed to move. So under geometry, I just selected all the radial holes. So once you have all the holes selected, apply. There should be 8 of them. And I left it fixed in all directions because the set screws should prevent it from rigid body motion in all directions. But there's, yeah, so that's what I use for this. There's lots of, you can do fixed support, displacement. Basically, you're just adding boundary conditions to your simulation. You can also add under connections like a joint between like two bodies or between the body and the ground. I'm not going to use that for this simulation, but FYI, if you want to like fix things to the ground or add like constraints to the ground, you can do that. I'm going to save because we did a lot of stuff. Has everything made sense so far though? So materials, geometry. If you have an assembly, set your contacts, and then which you don't have to do if you have a part, and then set your like restriction. In this case, it's the set screws. And so now we'll work on the mesh. So you do have like a limited number of, hold on, I wrote down what I did for the mesh because I always forget and then. Okay. You have a limited number of nodes, and that includes these nodes and also this takes up memory as well. So basically each of these little divisions, basically the computer does a little like force analysis on each of them, and then they like add them together in this matrix, and you can get like stress out basically. So the more you have, the better your result is. So I'm gonna just start by clicking on mesh and change the default size to 0.005. The default unit is in meters, so that's 5 millimeters. And then hit generate.
Sorry, what number did you use?
0.005. And so that's just like the default size. So then you can right click, insert, sizing. So now I'm gonna try to refine the mesh basically around where the load's applied. We only get so many elements, so you want to like kind of maximize, I guess. So if you just select, these are the eyebolt holes, geometry, apply, and then under element size, I'm going to set it to 1 millimeter, so 0.001. And so it automatically recognizes it as face sizing. Update. Okay, so you can see the mesh in the hole. It's like a lot nicer. I also, okay, I'll just stop because you guys' stuff might be loading. But it's kind of hard to do the mesh on like a first pass. Basically, usually you do your simulation, then adjust your mesh, get results, adjust your mesh, get results. So,
So for some reason, my mesh applied the 1 millimeter to the entire bulkhead. So it's a really fine mesh over the whole thing. I don't know if I missed something there, but if it's okay, like, will it tell me right away if that's too fine a mesh?
Yeah, or, well, when you go to run it, it will say like you have size limits.
Okay, so I should.
If you do, that's why you should kind of do the mesh last, I guess. I don't know. I guess it doesn't matter. But yeah, it will give you a warning when you try to run it. But I guess probably I'll show again, insert, sizing, and then I selected just the eyebolt holes and then change the size and hit apply. And you can use like the sizing on also edges, body, face, anything. I'll just automatically recognize what you're doing.
Okay, it worked that time. Yeah, I just missed that one step. Thanks.
So I also did, so if you go insert inflation, this basically does like multiple, like really small organized boundaries around an edge. So when you go to geometry, it automatically selects a body. And so we're wanting to do around these eyebolts. So select the bulkhead, apply. Boundary is the eyebolt holes. Apply. And I changed the layers to 3, basically because 5 was not working. And then if you hit generate, and it gives this warning, but I just kind of ignored it. So if you like zoom in on the holes, you can see how that's like a really nice fine mesh kind of around the holes. And I think that's all I did for the mesh, although I do kind of want to try to refine it more, but I think it's kind of a good overview of techniques. I guess another thing, I'm gonna try this, see if it makes the mesh any nicer. I just went insert, method, selected the bulkhead, text dominant, all quad. Oh wait, never mind. That doesn't work. For some reason, that method does not work with the inflation. I'm just gonna delete. Okay. I have to regenerate the mesh. I think, yeah, that's pretty much all I did for the mesh. I don't really want to try to do it too much on the fly because it will not run. Oh. But overall, the bulkhead mesh could be a little finer, I think. So now the only thing left to do is add our load. So on static structural, if you right click, insert force. So you can either apply force to a specific face, or you can do like if you're wanting to add like a specific location, there you can do like remote force. But in this case, it's on the eye bolts. So we'll select that. Apply. I always change the type, or sorry, defined by vector to components, because then it gives you X, Y, Z. It's just a little bit easier to work with. So in this case, we'll be getting 1,500 pounds on each face in the negative Z direction. So it's, is it negative Z? Yeah, negative Z. So I think that's 6,660 newtons negative. And so now you should see this little red arrow showing the direction of the force. So you can add all 3 force components if you had other ones, but it's just a vertical force component. And next, or like kind of last before you run the solution, is just right click on solution and insert. Basically, this is how you get your like plots, those like rainbow colorful things. They're really fun. So stress, I always do the von Mises stress. That's basically the typical failure theory for a ductile thing like aluminum. These other ones, I think these are usually for brittle materials, and these are not commonly used. So von Mises basically will give you your safety factor. I also like to insert deformation, total deformation, because if you can see how it deforms, it's kind of useful to know your results. Okay, is everybody on the same page? Nice. I will show you one thing that's kind of cool if you can get it to run. It won't run on this because it's like a big assembly, but like if you're doing this for work or something, or you have a part, like a small part, you can go on your stress, right click insert convergence and set that to like 5%. And basically what this would do is when you run it, it changes the mesh size until you get the change in stress is like less than 5%. I'll delete that because it's not going to run, but that's just a useful tool. So we're all ready to run. So you just right click solve. And I get this error message all the time when I'm running with like some frictional constraints, but I haven't had too much trouble with convergence, so I haven't I haven't changed that setting. Are there any questions while we wait for this to load?
Oh, in the past, we've always used SolidWorks, or most people have used SolidWorks for simulation. Is ANSYS way better, or like what's the appeal of ANSYS over SolidWorks?
I'm not 100% sure. For me, I'm just more familiar with ANSYS because I used it for co-op. And so I know my way around it a little bit better. For like structural FEA, I'm not sure that SolidWorks is really that much different. It'd definitely be worth trying to maybe recreate the simulation in SolidWorks.
Yeah, that's a good idea, actually. That'd be cool to see.
I'm not sure, because we have the full SolidWorks, so there might be a better mesh. But yeah, I didn't get much about that, but I know how to use ANSYS a little bit better. So, okay, the mine's already loaded. So if you go, here's the, okay, so I actually did not, oh yeah, when I ran this, I just ran it with half the load because I we had it mixed up. So I did not actually see this result. So there you go. Up here, if you want to probe, just tell you what the stress is. This is in pascals at any given point. You can also maximum, minimum. This is what I got last time too. The maximum's like right in this radial hole. If you go to, where is it? Oh, yeah, result. Oh yeah. If you, so this is like scaling up the deformation, but if you don't want that, you can change it undeformed. So you just see how it actually looks, or true scale. You can also, under edges, get rid of the mesh. And then you also have your deformation plot, which this is always kind of interesting. So that's basically how it's gonna deform under load. That's pretty low deformation. So that's, I wouldn't worry too much about that. So this is 89 megapascals, and aluminum is, the yield stress is 270, I think so. This is a safety factor of 3, as is. I don't know if we want to consider the force acting on just one, like if say one of the shock cords broke and then all the load got put onto one hole. I guess we might want to consider that.
With a safety factor of 3, in theory, it should be okay though.
Okay, yeah, I think
Right.
I was getting higher before, so I think I am gonna like try to improve the mesh a little bit to see if, because sometimes if you add more elements to the mesh, you get higher stress. But that's kind of the nature of FEA. You usually don't run it once, you run it a couple of times to make sure your results make sense. And also for something like this, if you're doing like stress analysis, obviously you want to check the shear pins and the eye bolts as well because they're not included. And I think that's all I have, unless you guys have any questions.
Yeah, so where is the safety factor? Like where do you see that?
Oh yeah, it doesn't import it. I just calculate it. Basically, you just take the max. You find the yield stress of whatever material the maximum is. So in this case, it's on the aluminum, and divide that by your max stress.
Okay.
Maybe there might be a way to import it, but I've never figured that out. I think SolidWorks does do that though.
And that's with the load spread between both eyeballs, right?
Yeah.
So it's 1,500 pounds on each.
Yes, I think so.
Okay.
That was fucking sick. The results look so cool.
Yeah, I always results. Another thing you can do. Oh, there's a way to like insert. Can't remember how to do it. I feel like I did this on a class or something. There's a way where you can like insert mesh parameterization, or maybe it's can't remember, but there's a way that you can do this parameterization, so it just like changes like the mesh size and just outputs the force, and then you can kind of graph like mesh size versus force and see how that changes. I guess I'll just stop the